Welcome to EDU World Space.
All right. Interesting question here that asks, can a 13-meter pole fit in a 10-meter, sorry, not 110-meter barn assuming someone is moving fast enough, right? So to answer this, we must invoke special relativity, which is the idea of length contraction, that length will be contracted in a moving reference frame. So let's start with the reference frame of the boy. Boy's reference frame. So in here, the key idea is that the pole is at rest with respect to the boy. And in the boy's reference frame, the pole has a length of 13 meters, right? Because it's not in a moving reference frame, so its length is not contracted. Okay, so it's still a 13-meter pole. However, barn contracts in length because, again, in a moving reference frame, length will be contracted. So the barn is not at rest with respect to the boy because the barn is not moving with the boy. So the barn is actually, it appears to the boy as if the barn is moving. So that means that length, let's call this LP for length of pole, and LB for length of barn, which has to be less than, actually it's less than, once you're moving, it has to be less than its rest length of 10 meters. Oops, 10 meters. So in this case, pole cannot fit into the barn. Okay? However, we can move to the rest frame of, we can move to the frame that is at rest with respect to the boy. Sorry, with respect to the barn. With respect to barn, here we invoke the length contraction formula, which says that proper length will be equal to rest length times square root of 1 minus v squared over c squared, right? And so the idea is that we want to find v given L and L naught. So the rest length for the pole is 13 meters, and the proper length, we want it to be 10 meters or less, right? So in order to fit it into a barn, so you can rearrange some terms and square both sides. You get 1 minus v squared over c squared equals L over L naught squared. And so this is actually, v is c times square root of 1 minus L over L naught squared. And so that's c times 1 minus 10 meters over 13 meters squared. And this works out to be 0.639 c. So in this frame, yes, it can fit. So interesting problem here, but knowing special relativity well enough can help you answer this.